Good morning, Anirudh. Can you hear me?
Google Meet.
Hi, sir. Good morning. I can hear you.
Yeah.
Can you hear me?
Thanks. Yeah, yes, Anirudh.
Okay,
Thanks for
great.
joining.
Thank
So
you.
we shall wait for another 5 to 10 minutes. So the
Sure, sir.
participants are gotten there. We can.
Okay, sir. Sure.
I request all the participants to pin Anirudh Rajagopal presentation. From the people list, you can see two things. One is Anirudh Rajagopal and another is Anirudh Rajagopal presentation. I request all the participants to pin Anirudh Rajagopal presentation so that you can see the presentation throughout the session. Please do not forget to pin a screen so that even if someone else is presenting, the screen will not be navigated. We shall start in another 5 to 10 minutes. We shall wait for participants to join. Good morning, participants. Warm greetings from St. Joseph's Institute of Technology. I request all the participants to pin Anirudh Rajagopal presentation screen. I request all the participants to pin Anirudh Rajagopal presentation. You can see two Anirudh Rajagopal from the people list. Select either one. Upon selection, you will see a presentation screen. When you see it, please pin. Please do not forget to pin the Anirudh Rajagopal to view the presentation. We shall start in another 2 to 3 minutes. Please wait.
என்ன பண்ற? யாராவது வந்திருக்கா பாப்போம். சும்மா 4 மணி வயசுல இரு. சரி, யாராவது வந்திருக்கா பார்ப்பாங்கல்ல. ஒரு யூடியூப் லைவ் ஓடிட்டு இருக்கு. கேட்குறேன் யூடியூப்ல. இதெல்லாம் கேட்கல. ஆனால் யூடியூப்ல கேட்குது. இந்த இதில் எனக்கு அவுட்புட் வருது. இல்லை, நான் இதில் வந்து செக் பண்ணுவேன். நான் யூடியூப்ல தான் இருக்கேன். இப்போ நான் பேசுகிறேன், ஃபீட்பேக் வருது யூடியூப்ல. நான் இதில் கேட்கல. பேசுகிற ரெக்கார்ட் ஆகும்.
A warm good morning and a warm greetings to all the participants. It's my pleasure to welcome you all for this webinar, Role of Mechanical Engineering in Industry 4.0. Now I request our speaker to display the department promotional video. I request all the participants to pin the Anirudh presentation screen to see the presentation and all the promotional videos. Anirudh, we can't hear the audio. Can you please change the settings?
Sir, are you able to hear the audio?
Anirudh, we can't able to hear you. Please, can you go to settings and change the microphone from microphone to stereo mix? Please go to
Okay, sir.
settings.
So the settings in the Google Meet,
Google
right?
Meet, Google Meet. Yes, yes. Bottom, you can see a three dotted
Got it, got
symbol.
it.
Click that. Go to
Microphone.
settings and
Yeah, microphone too.
microphone. It will be default. Have you wired it to the laptop?
Yes, sir. Yeah.
So just change it to stereo mix or Realtek high definition audio.
Okay.
Once you connected, you won't be able to hear me. I can't able to hear you. Now you play. Okay, Anirudh.
Yes, sir.
Yeah, we can't able to hear. Okay, you just stop. I will play the video from my side. You just stop presenting your screen.
Okay.
Whatever it takes.
வெபினார்ல இருக்கும்போது அது கால்ல இருக்கும்.
Thank you all. Now I request our beloved head of the department, Professor K. Arun Vasandagiran sir, to give away the welcome address.
Welcome everyone. Thank you for joining us for today's webinar. I am Dr. Arun Vasandagiran, Head Department of Mechanical Engineering, St. Joseph's Institute of Technology, OMR Chennai, one of the reputed engineering institutions in Tamil Nadu. It's my honor to represent St. Joseph's in its 26th year, which has a dynamic chairman, Dr. B. Babu Manoharan, under whose guidance we all excel. Always with us, our beloved Managing Director, Mr. Jesse Priya, and beloved Director, Mr. Saisi Segar, whose progressive ideas guiding us to achieve more. I wish to take this opportunity to thank our beloved Principal, Dr. P. Ravichandran, for his continuous motivation and support. Today's webinar is in the title, Role of Mechanical Engineers in Industry 4.0 Revolution, presented by Mr. Anirudh Rajagopal, Corporate Trainer, CAD Center. Welcome, sir. Industry is facing a historic turn point. In Industry 4.0, people, machines, and products communicate with one another via the internet. This means the convergence of industry and internet technology. In terms of manufacturing industry, factories of the fourth industrial revolution or smart factory will have the following characteristics. One, the industries will be automated and connected with each other with the dynamic and self-configuring capabilities on top of interoperable communication protocol. Two, they'll be intelligent, where the machines can be self-trained to solve new problems and provide training to other machines, that is machine to machine. And third one is technology. The technology enabled the human will monitor and execute the entire manufacture process anywhere in the world. Fourth one regarding the machines will have full control. Will have full control in the operation of manufacturing process, while data will be gathered and processed by business intelligence software created by humans. Modern machines will allow companies to exploit the potential of digitalization in their production facilities and to unlock new business fields. The mechanical engineering sector have to know how new technologies can be successfully integrated for the benefit of the customer. Digitalization goes hand in hand with the growing importance of platforms for data exchange, customer contact, and services. Online platforms facilitate market access, reduce transaction costs, and enable innovation through new business models. Machines obviously will be connected around the world, so Industry 4.0 would not be possible without networks and data traffic. Smart factories will allow increased flexibility in production. Automation of the production process, the transmission of data about a product as it passes through the manufacturing chain, and the use of configurable robots means customization. This will allow the production of small lots due to the ability to rapidly configure machines to adapt to customer supplied specifications and additive manufacturing. So, this flexibility also encourages innovation. A variety of different products can be produced in the same production facility. In addition, customers will be able to be more involved in the design process, even supplying their own modified designs, which can then be quickly and cheaply produced. We hope you will find today's webinar helpful, and we would love to hear any feedback you have. On behalf of St. Joseph's Institute of Technology, Department of Mechanical Engineering, and our webinar team, I warmly welcome you all again. Thank you.
Thank you, sir.
This is the future. Evolution.
Now I call upon Mr. R. Ranjit Kumar, Assistant Professor, Department of Mechanical Engineering, to give away the introductory address of today's speaker.
Thank you, Krishna. A very warm good morning to all. We are delighted to welcome the next generation engineers who are awaiting for the opportunities to bring in changes in the world that could benefit the mankind. This webinar on role of mechanical engineers in Industry 4.0 revolution will set the mood of rest of your day, and even it may tune your upcoming future. Technology unveils a new sophistication every day to the mankind. Well, we call that as innovation. Nowadays, the young and creative minds keep exploring the new horizon of science and technology and come up with new inventions. So, the scientific community understood the knack of fathoming the ocean of science and engineering and bring in surprising and enterprising things. They term that as cutting edge technologies. The growing economies have given the purchasing power to the masses and tinkered their thought process to match their desires. The so called mass production seem to be completely obsolete in the days to come. Well, you think about a product, industry version 4.0 and the subsequent versions give you the freedom to realize it in a way you wish to have it or you dreamt of it. That too within a short span of time. Isn't it magical? Isn't it dramatic? Yes, it is true. It is going to happen. The need to stay unique and to show off their money, people started to think of customized products. This is the time where and when market and commercial no longer increase the production and productivity. It is the taste of individual or a small group that decides and dictates how their product should be and wants to get them done in a very short span of time. Suppose you order, bang comes your product to your taste, not to go and search for the one which serves just half of your desire and dreams. Technocrats now must be flexible to adopt these manufacturing methods to go in quick reflexes to satisfy the design of customers. So, to tune yourself to be flexible and adaptable to the above said changing industrial revolution, you need an environment. And this is where our St. Joseph group of institutions expertise itself to provide its students several opportunities to keep abreast with the ever-changing technological climates of the globe with short and strong rudiments. The technical sessions like seminars, workshop, internship, innovative projects, interaction with high profiles and reputed industries, and research inclined projects makes you a person to be received with the red carpet in any current and upcoming version of industries. Yes, we make you capable of customizing yourself and to customize the incorporation in which you're going to be an inevitable part of it. So join and become a Josephite to rejoice the journey towards technological excellence. With this, let me now invite the expert who can reveal the myth around the chosen topic and to elaborate on the larger picture of it. I hope it will be quite insightful and interesting journey. I take pride in introducing Mr. Anirudh Rajagopal, whose prolific profile exhibits his passion towards designing. Mr. Anirudh, after his schooling, textured his career by adding bachelor degree in mechanical engineering at PES Institute of Technology, Bangalore. We need a wide aspect ratio to display his short but very effective and progressing career in design. He rendered his service as a head product design in global 3D labs for almost 3 years, during which he has involved in many design projects. Out of that, his design work of FDM 3D printers stands out. He then moved into a company named 3D as product designer and enhanced his 3D printer designing skills. Currently, he is associated as application engineer with Institute of Industrial Design, which is an integral part of CAD Center. He is also a trainer for more than 200 corporate people and college students. We wish him to reach greater heights in the future in the field of design that cannot be scaled. Without further delay, I would happily welcome Mr. Anirudh Rajagopal to take over the session. I also thank our beloved HOD for giving me this opportunity. Thank you all.
Hi everyone. I hope all of you can hear me. Is my voice audible?
Yes, Anirudh, you're audible.
Okay, thank you.
You can start presenting your screen so that we can ask the participants to pin your screen.
Sure, sir. I'll just do that.
I request all the participants to pin Anirudh Rajagopal presentation screen. You can see a presentation screen now from the people list. Please present to Anirudh Rajagopalan presentation screen. You can start the session right now.
Okay. Hi, everyone. I hope all of you can see the presentation which is going on. First of all, I would like to thank Ranjit sir, Arun sir, and Krishna sir for that kind introduction and their words on Industry 4.0. It was very, very useful. Even I learned many new things through that. One thing is, I would like to keep this session a little bit interactive. So maybe if you know the answer to certain questions which I'm asking, you can type it out in the chat box. Or if your chat box is not working, then maybe just unmute your microphone for a second and you can answer it. Okay. So my name is Anirudh. I'll start with this session now. I think Mr. Arun sir gave an introduction on this Industry 4.0. So I'll keep it a little bit shorter. Now, the term Industry 4.0 is a general term for what we refer to as the fourth industrial revolution. So during the history of mankind, we have had currently 4 industrial revolutions. This is something which most of you would have studied in school, probably in your history classes. But in today's class, in today's session, what we are going to do is elaborate on this Industry 4.0 and talk about how mechanical engineers can flourish during this fourth industrial revolution. So the whole point of this Industry 4.0, or what it revolves around, is on communication. So communication between both machine to machine, machine to man, as well as man to man communication. Okay. Now the term Industry 4.0 was actually introduced in the year 2011, and it has been used ever since then to describe the current advancement in the manufacturing industry as well as software and electronics. Okay. So before we get very technically into what makes up this Industry 4.0, let's talk a little bit about basically a little bit about the history of the industry and how we reached this stage in our human evolution. So I think all of you will be familiar with a lot of this, but anyway, it will be a good idea to go through the history to understand how we have come to this stage. Now, it was the first industrial revolution when we talk about. It started in the year 1760 or in the 18th century and lasted up till about the 1830s. So during this first industrial revolution, it was the first time in the history of mankind that humans started to use machines to perform activities or to perform machinery work or building activities. So it was with the introduction of the Watt engine or the Watts engine that human labor was replaced by machine labor. So this marked a significant change in the history of humanity, which has allowed us to become the most dominant species and to separate ourselves from any other species. So the development of this Watt engine, which would allow machines to do work rather than us to do work. It marked a huge change in your social and economic growth in the history of mankind. So this sparked the revolution of mankind from being a species which you could associate with other animals to something which is a little bit advanced in that. So we could consider the time span of our first industrial revolution to be between 1760 and 1830, approximately. Then marked the second development in the history of mankind, which we call as a second industrial revolution or Industry 2.0. So during this industrial revolution, what was significant was the use of or the build of railroads, so that machinery, equipment could be spread all over the world in a much faster way. So initially, we started replacing human labor with machine labor so that a lot more work could be done for a lot less amount of effort. And in the second industrial revolution, we started spreading this world over. So in the second industrial revolution, what marks it out was the invention of the steam locomotive or the train. And this used James Watt's technique or James Watt's engine to power it. So the second industrial revolution was when a lot of the railroad, a lot of communication was spread around through railroad from the time of 1830 to the 1870s. Then we started focusing on the third industrial revolution. So the third industrial revolution was actually it was a very, very long industrial revolution. It was from the 1830s till about the 1950s or 1960s. So during this time, again, what happened was the railroad network started expanding a lot more. The invention of the airplane was made, so therefore transportation of goods and services could be made a lot easier. And also, what really marked off this third industrial revolution was known as the Z1 calculator. Okay, it was the first electronically enhanced calculator which was developed in the world, which was developed in the year 1955 or 1956, around that time. And then currently, what stage of humanity we are living in is known as the fourth industrial revolution. So, what has separated the fourth industrial revolution from the remaining ones have been the invention of this Internet of Things. Okay. So, with the invention of what's called this Internet of Things, or with what the development of what the Internet of Things have been, is what has started off or sparked off the fourth industrial revolution. Okay. So, this is a brief history of this industry, of how it occurred. And now, the next thing that we're going to talk about is what makes up this industry 4.0. So these are called the pillars on which the fourth industrial revolution is built upon. Okay. So I would request any of you, if by any chance you can't hear me, or if you want me to go over anything again, please feel free to ask me at that time, and I will do it again. But right at the end of the session, we will have a question. We will have a question and answer session for about 5 to 10 minutes. Okay.
ஹலோ குட் மார்னிங் மேடம் சொல்லுங்க மேடம்.
Okay, so let's go through these pillars of the Industry 4.0 revolution and what this Industry 4.0 relies on. So I think Arun sir mentioned at the beginning, and I'm going to repeat the point again, that the Industry 4.0 is all about communication between machines and humans to machines. So the pillars on which this Industry 4.0 depends on are the following. We have what's known as your additive manufacturing, or probably more commonly known as 3D printing.
இல்ல இல்ல
Then we have what's called your simulation. So
இல்ல
simulation
கேட்ல
is
தொங்க போட்டுருக்காங்க மேடம்.
something
காலையில
which
நான் போறதுக்கு முன்னாடி
we
ரெண்டு
will get
சாவி
into
உண்டு,
in
3
detail
சாவி
a
உண்டு.
little bit later. But
ஒன்னு
it is
என்கிட்ட
very,
இருக்கும்,
very
இன்னொன்னு
key and very,
சதீஷ்
very
அவன்கிட்ட
essential to the
இருக்கும்,
mechanical
இன்னொன்னு
field
சோடிச்சு
in
இருக்கும்.
the current
அந்த
industrial
சதீஷ்
revolution.
சாவி எப்போ என்ன பண்ணுவோம், எப்பவுமே கேட்ல போட்டு
Then we have what is called your robotics, which I'm sure all of you will be aware of. You have robots all
ஆமா.
around you. Nowadays, if you see Amazon,
ஏத்தர்
if you see a
ஏத்தருக்கு
lot of other
சாப்பிடும் தேவையா?
delivery companies, they are actually using drones and
அது
using
சின்ன
other
ரூம் தானே
robots
மேடம்,
to
அதே
deliver their
கொடுக்குறாங்களா?
equipment. And I think currently in either Korea or Japan, because of this whole COVID situation, there was a whole wedding which was conducted by using, instead of audience members, they had a TV monitor
நேற்று
placed
தான்
on the
எழில் சார்
robot,
போனார். எழில்
and
சாருக்கு ஒன்று இருக்கும்,
the entire wedding was
கேரமெச் ஒன்று
conducted
இருக்கும்,
like that. Only the bride and the
ஆர்த்தட்
groom
ஒன்று
were
இருக்கும்.
present in that hall.
ஏ சதீஷ்
Okay. So robotics, simulation, and additive manufacturing
நாளைக்கு
are the three
இன்னைக்கே
most
கொடுக்கணுமா?
obvious ways in which a mechanical engineer can flourish in the fourth industrial
ஹெச்ஓடி
revolution.
ரூம் கேட்குறதுல
Then we get on to what has actually sparked the fourth industrial
அது
revolution,
கேட்லயே போட்டுருவாங்க.
which is known as the Internet of Things,
இவங்க தான்
or it is
எழில்
sometimes
சாரும்
called the Industrial Internet of Things. Since we
கேரமெஸும்
call it the
பிரதாப் சிங்
Industrial
வச்சிருப்பாங்க.
Revolution, we also call it the Industrial
ஆமா ஆமா, அது நம்ம காமனா வாங்குறது.
Internet
அவங்க
of
தான்
Things.
பூட்டி அவங்க தான் திறக்கறாங்க.
Then we have the next one, which is known as your virtual reality and augmented reality. Also, short form
அதுதான்
is
சொல்றாங்க
VR
உங்களுக்கு.
and AR. And I'm sure maybe
HOD
all of you will already be
திறந்திருப்பாங்க
aware
மேடம்.
of this. We have your Oculus Rift.
HOD ரூம்க்கு திறந்திருப்பாங்க.
It's a virtual reality headset which you wear.
அப்போ சில ஸ்டாஃப்
Then
ரூம்
even
இவங்கள
Samsung
உட்கார்ந்திருக்காங்கல்ல,
developed
நம்ம என்ன
a couple of
பண்ணிட்டு
virtual
இருக்கோம்?
reality products.
லைப்ரரி.
And
எழில்
I'm
சார்
sure all of
இவங்கள
you would have seen
கார்த்தர்ல
videos of this.
உட்கார்ந்திருக்காங்கல்ல.
But what my job is today is to
அதுதானே
tell you
கேக்குறீங்க.
how, as a mechanical engineer, you can apply yourself in all of these fields and how you can flourish in the future. And then we have what's known as big data.
எல்லாமே
So
அந்த
big
ஸ்டாஃப்
data
கையில தான் இருக்கு.
is
இப்போ ஏசிடி
something
ஸ்டைல ஒரு
which
ஸ்டாஃப்
you may
ரூம்
not think
இருக்கு,
of
வாய்ப்பு இருக்கு.
too
ஆனா
much
எடுத்துட்டு
related to
போனாரான்னு
the
தெரியல.
mechanical engineering field, but trust me, it is very, very important to be a mechanical engineer in order to access
கால்
all this
பண்ணி
big
என்னென்ன
data.
வாய்ப்பு இருக்குன்னு
Again, I'll be
கேக்குறேன்.
telling you
எழில்
about
சார்ட்டையும்
how it will
கேக்குறேன்.
help us. Then we have the next pillar, which is called as universal integration.
சரி சொல்றேன் மேடம்.
So universal integration is something to do with your entire production line, your entire
ஓகே ஓகே.
software, hardware
ஓகே ஓகே.
systems which
ஏசிடி
you have
கேட்டா
in a
தெரியும். ஸ்டாஃப்
factory
ரூம்
or
ஸ்டடி
which you have in
யாரா
an industry,
1
or
to
even
2
which you
இருக்கு,
have in
தனித்தனியா
services.
வச்சிருப்பாங்க.
Then the
நாளைக்கு
next pillar we have is what's
ரெண்டாவது
known as cyber security. This is something which is very, very essential these days, especially when it comes to
வெங்கடேஷ் சார் போறாரு.
sharing data online and communicating online. So with the onset of communication, with sharing data
பார்க்கலாம் நம்ம ஆளை
online,
கூட மாற்றி விட்டுக்கலாம்
the
போகிறது
cybersecurity has
மாற்றி விட்டு
become
கூட
very, very
போயிடலாம்
important.
கீ எடுத்துகிட்டு போய்
And then the last pillar we have is your cloud computing. So
எடுத்து எங்கே ஒன்று லேப்ல
these are the
கொடுத்துருவாங்களா
9 pillars which we have in this industry 4.0. And what my role is in the next probably half an hour or so, I'll be explaining how you can apply yourself as mechanical engineers into all of these fields. Okay. So let's talk about the first pillar, which will be your additive manufacturing. Okay. So, see, interestingly, the term additive manufacturing or 3D printing was developed in the year 1985. But the reason why we associate this most with your fourth industrial revolution was because the person who started this term additive manufacturing or started additive manufacturing, his name was called Charles Hull, and he patented his technology and would not share it with everyone. So his patent lasted for about 25 years. And in the year 2009 or 2010, that patent expired. And he wanted to increase it for a few more years, but he fought a court case and lost against it. And that's why probably around 10 or 11 years back was when 3D printing really started to explode in the market. Because there would be a lot more people who could enter the 3D printing space, use the same technologies and develop different types of 3D printers and make it more commonly available to everyone. So currently 3D printing is what we would consider as a prototyping process, meaning rather than making something which actually works or something which is used in manufacturing, you will make what's called a prototype of a model. So the initial model is what we would make using 3D printing. But slowly, what's happening is that 3D printing is going to substitute your prototyping, it's going to substitute your manufacturing processes in the future. So probably in the next 5 or 10 years, 3D printing is going to become one of the primary manufacturing processes. And as a mechanical engineer, manufacturing is the core of what you'll be doing. And 3D printing is something which you can really, really focus on and develop your skill set with respect to the fourth industrial revolution. Trust me, if you know 3D printing, if you become very, very good at 3D printing in the next few years, then for your future, for the foreseeable future, you are very, very set in life. Okay. And it is one of the essential pillars of your fourth industrial revolution. See, all said and done, your communication can be one thing, but then the machines to develop them, that's something which mechanical engineers are essential. Okay? And to give you a scope of what 3D printing is going to be just in India, is that by the year 2022, it is estimated to be a $79 million industry. Just in India. And world over, it's going to be much, much more than that. Okay, so you probably multiply that by 100 and you'll get the actual value of what it will be world over. Okay. So 3D printing is the first pillar, or additive manufacturing is the first pillar of our fourth industrial revolution. And how it helps is that it is going to become a primary manufacturing process in the near future. So actually companies like BMW and Mercedes have also integrated 3D printing into their current manufacturing process. Then the next pillar which we'll talk about will be called your simulation. So talk about simulation. What I mean is simulation of certain processes to simulate a machine working in a certain environment. So it's the usage of a CAD software, meaning a computer-aided design software, which there are many of, to simulate certain processes to check whether a machine or an object will work in the real world. Currently, okay, in terms of the automotive industry, till about a few years back, what was happening was, so how the design process used to work was, they would create a vehicle, okay, design it, finally do a lot of analysis on the software, which is known as your simulation. But then they couldn't rely too much on the software. So what they would do is they would actually create the model of this, import it onto your simulation software or onto your analysis software, and then do a little bit of analysis. And then after that, they would create a prototype, and then they would, maybe all of you have seen it on TV. They would show you videos of crash testing, videos of putting the prototype in a wind tunnel and showing you how the airflow occurs over it. So rather than doing that, what is being done nowadays is the exact same model or the replica of a model is
சரி ஓகே
created,
நான்
it is
வெளியில்
scanned,
தர
it
பேசுகிறேன்
is
என்ன
taken
பண்ணலாம்
onto a 3D software.
அல்ல எஸ்
And
எஸ்
instead of
எம்சிசி பேச
actually
எலிசா பேசுவா
physically doing it, we are, as mechanical engineers, we understand all this
எம்சிசி பேச
airflow, we
எலிசா
understand a
பேசுவா
lot of
இல்லைன்னா
these processes, and we are going to replicate the same environmental
சரி ஓகே
processes
பேசு
in
என்ன பண்ணிட்டு இருக்கீங்க
our 3D software. So instead of actually physically making a model, we are
கூட
saving a
யாராவது
lot of time and money by simulating it on a software. Okay, so that's where your role as a mechanical engineer
சாப்பாடு
will be,
கொண்டு
because
போயிருக்கீங்களா
you are familiar with the entire design process, how you have
இது
reached
என்ன
that stage,
மாஸ்க் போட்டிருக்கீங்களா
and basically what you are doing is
மாஸ்க் கிளவுஸ்லாம்
you
போட்டிருக்கீங்களா
are performing your crash testing and your CFD analysis, which is your flow
சானிடைசர் அங்கே
analysis,
வச்சிருக்காங்களா
on the software rather than creating the vehicle and actually doing
அவங்க
it.
வச்சிருக்கலையா
So it
காலேஜில்
saves a lot of time and money. And honestly, that is what people will
டெக்னாலஜி
invest
எதுவும்
in right
கூட்டமாக
now.
தெரியுதா இப்படி
Okay? So simulation is the second
டெக்னாலஜி
most
எதுவும்
obvious
கூட்டமாக ஆட்கள்லாம் இருக்காங்களா
here
இப்படி
when it comes to your mechanical engineering and your fourth industrial revolution. Then the third most obvious thing, which all of us will be familiar with as mechanical engineers, is your robotics. Okay, so robotics is something which has a very, very wide range, and it consists of
சரி ஓகே நான் வெளியில் தர
different,
பேசுகிறேன்
it's a multidisciplinary field, meaning it is not just to do with mechanical engineering, it is to do with mechanical as well as electronics as well as your computer sciences. Okay, it is not just enough to resist yourself or to contain yourself to know just your mechanical engineering concepts, because what the modern mechanical engineer should know is a little bit of electronics and a little. Suppose I am sitting at home, I have some spare parts lying around. I don't want those spare parts to go to waste, because right now, again, with the fourth industrial revolution, what we are looking forward to is reusing these spare parts and updating them and upgrading them so that we can use them in a much more innovative way. So I think Arun sir was talking about innovation in the fourth industrial revolution. So it is essential for a mechanical engineer to know about how we can utilize these apply them into a different field. So we not only have to know mechanical engineering, but we also have to know a little bit of electronics and a little bit of computer sciences as well. Okay. Your robotics does is for automation. So again, I think Arun sir spoke about these smart factories. So what is a smart factory? A smart factory is a place where the entire production line is automated, basically. In essence, that's what a smart factory is. So it is automated by programming the robots to perform all the operations. Okay. So these are the three most obvious ways in which we can apply ourselves in the fourth industrial revolution, or in the main pillars of the fourth industrial revolution. But now let's get down to something which is a little less obvious, but equally as important. So we have what's known as the Internet of Things. So see, even though the fourth industrial revolution was set to have started in 2010 or 2011, the actual term Internet of Things was developed or was first introduced in the year 1999. So it was 10 years or 12 years before the fourth industrial revolution actually started. The thing is, all of these what you call buzz terms, all of these important concepts take little time to develop. So over 12 years, it started gaining traction, and then when it became a primary source of what is going to fuel the fourth industrial revolution, that's when the term Internet of Things really exploded. So again, all of you would have heard about this term Internet of Things, but it really exploded only in the year 2011, even though it was developed in 1999. Okay. So basically, what Internet of Things is related to is to connect devices together. Okay. So now I'll speak a little bit from my experience. So when we were developing these 3D printers in my first company, you might think that, okay, you actually have to be physically present to put a design into your printer so that it can print the part which you want. But through the Internet of Things, what has been done is that we develop these electronic products, we actually manufacture them, and we place one in the printer so that the printer can understand that even though we are not close to it, we might be sitting in Bangalore, one person might be sitting in Chennai, and suppose I want to control a printer which is there in Chennai, I just have to put a very, very small device in it, and I will be able to communicate with my printer over there. Okay. So what the primary purpose of this Internet of Things is to set up
கூப்பிடு
communication between
உங்ககிட்ட வேணா அது
devices.
சுரேஷ் சார்ட்ட கேட்டா அப்படி
So that's why
ஜெய்சே அப்படி
this
3 வட்டியும்
industry
வாங்கிட்டு
4.0 is
போச்சுன்னா
all
வேலை
about
முடிஞ்சிடும்.
communication. And that's why the Internet of Things is what sparked off this industry of 4.2. Okay. Communicating
அதான்
between
சார்
devices.
ஏத்தரும் சின்ன ரூம்
And
தானே
if you
மேடம்
see
அப்படிங்க.
companies like IBM,
இல்ல அவர் வந்து
yeah,
அங்க
companies like
இருக்காரு
IBM and
கேட்டிருக்கேன்.
all are
இல்ல
heading
கம்ப்யூட்டர்
this
சேஃப்டி இல்லையா கரடி
entire
உடைச்சு எல்லாத்தையும்
thing of this
பண்ணிடுவான்.
Internet of Things. So
இதை கரடி போடுறதுக்கு முன்னாடி தெரியணும்.
your role as a mechanical engineer when it comes
கம்பி
to
போட்டு என்னது
IoT
பிரச்சனை வருமா
will be to
ஓடி
develop
தூக்கி
these
தூக்கி
sensors
ஃபிட் பண்றது.
and drivers, not
கம்பி போட்டு
drivers,
என்ன
to
தேஞ்சா
develop these
போயிட போறாங்க.
sensors and embedded actual physical objects which are
ஆமா
needed
கஸ்டடி
to
ரூமு
make these connecting devices. See, we
ஸ்மார்ட்
can't
கிளாஸ்
just
மாதிரி கேட்பேன்.
create something and not have
எங்க
something
எய்த் ரூமு
like
2
receiver.
ஸ்டாஃப் ரூம் நம்ம ஃப்ளோர்ல.
When you talk about
சிவிலுக்கு
robotics,
அங்க
we
தனியா
have what's
பேசிப்பாங்க
known as
அந்த
a
லேபரேட்டரி பேசிப்பாங்க
sensor and a
நினைக்கிறேன்.
receiver. Okay, so
லேபரேட்டரி
the receiver
இன்ஸ்ட்ரக்ஷன்
will receive this
கம்ப்யூட்டர்லாம் கலெக்ட் பண்ணி
information,
சொல்லி
and the
கிஷோரை
receiver is
நாளைக்கு
not just
அனுப்புறாங்களாம்.
it is a physical object. So a mechanical engineer will design or will
cool.
develop this physical object. So
okay.
our role will always be there
இங்க கூட தான்
in terms
எம்சிஎஸ்
of
பேசணும்.
this Internet of Things. Okay, and it is very very essential. So even if you think about it, no, your smartphone, you're holding a smartphone in your hand, and it is receiving internet. You are looking at this presentation because it is connected to the internet, and we are doing all this over the internet. And there are certain receivers, there are certain signaling emitting devices inside the phone, which has been developed by designers or by mechanical engineers in whichever phone company you have bought your phone from. Okay, so that's why the role of a mechanical engineer will always be there when we talk about this Internet of Things. Okay, then let's talk about something which is a little bit more obscure, which is known as your big data. Okay, so I'm sure all of you also would have heard about it. Okay? Then the last thing I wanted to talk
உங்க
about
இது இருக்கு
would be
1 வந்து அங்க
what's
இருக்கு
called
2
your
வந்து கிருஷ்ணகுமார் கிருஷ்ணகுமார் வந்து
design for
கண்டுபிடிங்க
additive
கொடுத்துறோம். நீங்க
manufacturing.
சொல்லுங்க மேடம்
So additive manufacturing or
அப்படின்னு
design for additive
சொல்லிடுவோம். நம்ம
manufacturing
சொன்ன
is again
இருப்பாங்க
something
நான்
which
எப்படி
is
பண்ணணும்.
going to be very very important, okay, for you.
சொல்லிட்டு அப்படி
Especially if you're joining the mechanical industry
வெங்கடேஷ்
field
சார்
now.
வந்து ரஞ்சித்
Design for
வாங்கிட்டு
additive manufacturing is something which I
அப்படியே
would
அவுட்டர்
highly
ரிங்
highly recommend
வழியா
that you
வந்து
get
எழில்
into.
சாட்டியை வாங்கிட்டு
Because
இங்க வந்து கிருஷ்ணகுமார் வந்து எப்படியா ஒரு
if you okay, maybe some
9:30
of you are
முன்னாடியே
familiar
வந்து
with this
அந்த
that
ரோயல்
Bugatti
ரோட்ல
Chiron,
கொடுத்துட்டாங்கன்னா
or
அப்படி வாங்கிட்டு
that
வந்துருவாரு.
the replacement for the Bugatti Veyron
இங்க
which is
அரேஞ்ச் கூட
developed.
நீங்க சொல்லிருங்கன்னு சொல்லிடுவோம்.
So the brake calipers for this
வெங்கடேஷ் சார்ட்ட
Bugatti
சொல்ல
Chiron
சொல்லிடுவோம்.
are
வெங்கடேஷ் சார்
each individual
கிருஷ்ணகுமார்ட்ட சொல்லி
brake
வாங்கி
calipers
கொடுத்தோம்.
actually 3D printed. Okay,
வெங்கடேஷ் சொன்னா
so
கிருஷ்ணா கேப்பாப்ல
how the design was made was they took a traditional
அப்படி சொல்லிடுறேன்.
brake caliper and then
நீங்க
they
சொல்லிட்டு நான்
actually did
சொல்றேன்.
some
நீங்க
stress
அவர்ட்ட அப்புறம்
analysis on it.
வெங்கடேஷ் சார் அவரே
And
பேசுவாரு
after they did
உங்ககிட்ட.
this stress
நீங்க கான்டாக்ட்
analysis,
பண்ணிக்கோங்க.
they found out areas where there is maximum stress and where the stress reduces and where there is minimum stress. Oh, okay. There are a lot of parameters which govern this, but basically this is what they did to create this design. Okay, this is just a simple design; it's not the same thing. But then the maximum stress regions are there over here. So the modern designers, what they do is
ஃபில் பண்ணிட்டியா?
the region where there is maximum stress, they will either add more material or add more stiffeners or add more
என்னடா லைவ் அப்படி
areas over
எடுக்குது
there
இப்போ?
where the stress can be relieved easily.
ஒண்ணும் சொல்லி இது வந்து இதுல தான் போட்டுருக்கேன்.
Because you want to save material, you want to save cost, and you want to save time with your
யூடியூப்ல
design
லைவ் பார்த்துட்டு இருக்கேன்.
and your manufacturing. Okay, so modern design follows this process. We create a simple design, we test it out, we do the analysis on it, and then based on this, we streamline your design and we design for what's known as additive manufacturing. Okay? So there are lots of examples of this. Airbus, Boeing, they are developing completely new engines, and they are 3D printing the entire thing. Likewise, the seatbelt harnesses or the seatbelt buckles. which
மேடம்
are
இந்த
made, earlier they used to be a
நான் எழில்
single
சார்ட்ட
block,
பேசினேன்.
and it used to be very very heavy.
எழில் சார்ட்ட
But now what's happening is
இருக்கு.
they are creating designs like this
இப்போ
so
வந்து
that there are
ஸ்டாஃப் ரூம்
holes in
1
the
2
middle,
வேணும்.
and
1 வந்து ரஞ்சித் கிட்ட
there are
இருக்காங்க.
holes in the
நாளைக்கு
middle,
வெங்கடேஷ்
and
சார்
the
தான்
areas
வராரு.
where the stress concentration is more, they have
அதனால ரஞ்சித் பக்கத்துல தான்
added more
இருக்கான்.
material, added more stiffness over
ரஞ்சித்
there to reduce
வாங்கிட்டு
the
அப்படி
stress at
அவுட்டர் ரிங்
those
வழியா
points.
வந்தா
Okay.
எழில்
So
சார்ட்ட
in
வாங்கிட்டு
doing
இங்க
so, they are saving material.
2 வந்து
Therefore, they are
கிருஷ்ணகுமார்ட்ட இருக்கான்.
saving weight as well. Okay.
கிருஷ்ணகுமார்ட்ட
So the
வந்து
entire airplane,
அவங்க
I think
துறைப்பாக்கம் தான்
recently,
இருக்காப்ல.
maybe in
வந்து
2019
சோழிங்க
July or
பக்கத்துல வந்து இங்க
August,
கொடுத்துட்டாப்புனா இப்படி வாங்கிட்டு அங்க போயிடலாம்.
Boeing
நாளைக்கு
developed an entire, or sorry, Airbus developed an
இன்னைக்கு
airplane with
முடியாது.
how many ever
நாளைக்கு
3D
வரும்போது
printed parts
வாங்கிட்டு
they could,
வரலாம் அவங்க.
and the entire weight of the airplane fell by about 40%. So imagine that. You can build an entire airplane
நீங்க
for
தான் சொல்லணும் கிருஷ்ண. வெங்கடேஷ்
40%
சார்ட்ட நான்
or for
பேசுறேன்.
60% of what your current airplanes are being built at.
சித்தி
by using
வெங்கடேஷ் சார்
3D
கிருஷ்ணகுமார்ட்ட சொல்லிடுறாப்ல.
And also,
இந்த
in
அதான்
doing
அரேஞ்ச்மெண்ட்
so,
தான்
we'll be
பண்ணிருக்கு.
saving
வெங்கடேஷ்
a lot
சார்
of
ரஞ்சித்ல வாங்கிட்டு
fuel,
வர்றவல
so
எழில்
therefore
சார்ட்ட
the world will
வாங்கிட்டு
become a greener
கிருஷ்ணகுமார்
place,
இங்க சோழிங்க பக்கத்துல வந்து
and
கொடுத்தாங்கன்னா வாங்கிட்டு
also you'll be
காலேஜ்
saving a
வந்துடலாம்.
lot more material. So
வேற எந்த
it
ஆப்ஷனுமே
is
இல்லை. ஏசிபி
a
செல்ல,
win-win
எம்சி செல்ல,
situation
சுரேஷ் செல்ல
completely.
எல்லாத்தையும் பேசிட்டேன்.
Okay, if you
யார்ட்டையும்
learn
இல்லைன்றாங்க.
this design for additive
இல்ல ஊர்ல
manufacturing.
உள்ளவங்க தான் இருக்கு. அஸ்வின் கண்ணன்
So
இருக்கு,
again, how
பிரபுராம்
it
இருக்கு.
happens is you create a traditional
அப்படி
design,
ஊர்ல உள்ளவங்க தான்
and then
இருக்கின்றாங்க. லோக்கல்ல இருக்கவங்க இவங்க கூட தான்
after
இருக்கு.
that you
இந்த பாசிபிலிட்டிஸ்
do
தான்
some
இருக்கு.
analysis
நீங்க
on this,
பேசிட்டு வெங்கடேஷ் சார்ட்ட சொல்றீங்கன்னா
and
வெங்கடேஷ்
then
சார்
you
கிருஷ்ணமூர்த்தி
redo the design based for your additive manufacturing part. Okay,
அப்படி அதான்.
so
ஆமா.
I think this is pretty much all I have to cover right now.
ஓகே ஓகே.
So
சரி ஓகே.
right now for the next about 5 minutes or 10
என்ன
minutes,
வெங்கடேஷ்
you
சார்
can
அந்த
ask me any
அரேஞ்ச்மெண்ட் சொல்லிருங்க,
questions.
அவர் பண்ணிடுவாரு. அவர் எல்லாருக்கும் ஃபோன் பண்ணி கனெக்ட் பண்ணி விட்டு
Thank you, Anirudh. It was really a wonderful session.
ஆமா.
Participants, you
எழிலரசர்ட்ட
can post your
ரஞ்சித்தை வாங்கிட்டு
clarifications, questions which you
எழிலரசர்ட்ட
would like to
வாங்கிட்டு
post to Anirudh in the chat box.
இங்க வந்து துறைப்பக்கத்துல சோழிங்கல பக்கத்துல துறைப்பக்கத்துல கிருஷ்ணகுமார்ட்ட
Yes,
வாங்கிட்டு
Anirudh, we can get into the Google Meet in the chat box.
Yes, sir, sure.
If you have any queries, you can address.
அந்த
Sure,
அவுட்டர்
sir.
ரிங் ரோட்ல வர
I'm
சொல்லுவாரு.
actually in
அப்படிதான்
my
வருவார்.
Google
அந்த
Meet
ஆவடியில
screen,
இருந்து
so
அவுட்டர் ரிங் ரோட்ல வந்து தாம்பரம் வழியா கீழ இறங்கி வரும்போது இந்த முடிச்சொல்ல வாங்கிடுவாங்க. அமையல் சார் முடிச்சொல்ல வாங்கிட்டு இப்படி நேரா சோழிங்கர் ஜங்ஷன் வந்து துறைப்பக்கத்துல இருந்து இவன் வந்து கொடுத்துட்டானா வாங்கிட்டு வந்துடலாம்.
Guys, does anyone have any questions?
செட் ஆகிப்புறம் நீங்க வெங்கடேஷ் சார்ட்ட ஃபாலோ
You can
பண்ணுங்க.
ask any questions. I understand Tamil also. You can ask in Tamil.
ஓகே.